Good morning, everyone. I'm Dr. Vimala Roselin, Assistant Professor in Christy Jayanti Institute of Technology. I'm going to explain about the conventional neural network, that is a CNN. This is a one part of ANN. It is an artificial network. CNN, RNN will be there. And this conventional neural network is a very important neural network in the neural network, artificial neural network. It is a neural network architecture inspired by the human visual systems and widely used in the computer visual vision techniques and image classification. So use cases the given CNN is used in the image classification. It is used to classify whether the given animal is an image is a cat or tiger. So two images we have given. One is a cat and another one is a dog. So in the conventional layer, many different layers will be there. Using the layers, we can convert, and what is the output you will get in the conventional layer network. And here the real world applications also given for the CNN. One is a Google Photos. Google Photos automatically classifies and groups photos by the people, object, or the scenes, objects, or the skins. And one more thing, it is used in the Apple Face ID. iPhone, we have used the CNN. iPhone is based on the CNN only, and test autopilot. Autopilot, they use the CNN conventional layer networks in the deductions and penetrations and recognitions and traffic design reductions. And convolutional neural network, um, uh, the history is 1977, the Fukushima conceptualized neural network, and 1989 modern CNN was developed by the Yarn. And CNN is a type of artificial network, and it performs the conventional operations to construct the learning model, and it is used to predictions and developing the AI applications, decision making systems, and also it is used to process and analyze the images and video data, audio data, and test data, time series data. So here some tasks they given. CNN tasks they divided into two parts. One is a feature learning and another one is a classification learning. Feature learning means it's extracting the features and creating the feature maps, and classifications means fully connected neural network classifications. In the feature learning, there are different types of layers will be there. One is a convolutional layer and pooling layers. And in the classification layer, there are three types, fully connected neural network. So it is mapped with a future map, and it is converting, cleaning, everything will be doing using the future mapping, and it is converted into fully connected. In that, many outputs will be there, and it is also converted into the input layers, and it is converted all the inputs into the new network, and it will find out or predict the input values. Here the image classifications, we given the input layer as a pixels value or the matrix values. So after all the values are given to the trained CNN, and in all the input layers in the CNN is converted there, and it is recognized and converted into the CNNs, and it will send it to the um, layers, send it to the fully connected layers, and all finally it will use the correct output values. So this is the CNN architecture, conventional neural network architecture for image classification. Here three layers in the CNN concepts. One is a convolutional layer, another one is a pooling layer, and fully connected layers. In this layer, the image we are giving as a matrix form. So all the images are converted into the pixel matrix. For example, here the cat image is converted into the 5 into 5 image matrix, and it will send it to the conventional layer. Conventional layer so has used the different types of functions, that is a ReLU functions or activation functions, like that. Many functions will be there, all the functions it used. So first convolution layers, it is responsible for extracting the important features from the input data, and it applies a set of learnable filters that slides over the images and compute the dot product between the filters, weights, and corresponding images, patches, product features, feature mapping. It uses the small filters, either 2 by 2 or 3 by 3 or 5 by 3 to scan the input images and generate the feature maps that captures the patterns such as edges, textures, and images. That is there in the conventional layers. And a pooling layer. Next one is a pooling layer. Pooling layer, it is used to reduce the spatial dimensions of the feature maps and making the computational faster and reduce the memory usages and helping to prevent the overfitting. It is typically inserted between the conventional layers is a CNN. At common types include the max pooling and min average poolings. Two poolings will be there. One is a max pooling and min pooling. Common types we used in this maximum, we are using the max pooling, and it is used to reduce the width and height of the layers, height of the images, while keeping depth unchanged. Then in future map, it reduces the matrices and converts in the future maps. So all the steps, so it will be done. By the feature maps, and it will convert into the flattening. Flattening means 1 by 2, 1 by 1 matrix. So after that, all the matrices pixels values given to the fully connected layers. In the fully connected layers, 3 layers will be there, and one is an input layers, and another one is an activation convolution layers, and the last one is an output layers. Input layers receives the raw images data and passes into the network for the processing. But in the CNN, inputs are typically three volumes of data, that is an width, height, depth. It stores the pixels values of the images, 32 bits or 62 bits or 64 bits. It's like that for the RGB images. It preserves the spatial structures of the images for the further features extractions. And inside the layers, that is an the hidden layer, all the activations, all the input values will go to the hidden layers. All the hidden layers converted into the simple layers, and it will send it to the output layers. Finally the output will predict by the output layers, and it will send the output images. So in between, we use the activation functions using the activation layers. So in the fully connected layers, performs a high-level reasoning using the extracted features and produces the final classification scores. And the next one is an output layer. In the output layer, converts the final scores into the probabilities using the activation functions like the sigmoid functions or the binary classification functions or the softmax functions or ReLU functions. So this is the architecture for the CNN concept. Thank you.